Welcome back, deep divers. Today, we're taking a look at some really cool research in solar.
It's about time, right?
Yeah, it really is. So we've got this article from the International Society for Optics and Photonics.
Oh, okay.
Yeah, and it's called, get this, Durable and Transparent. Researchers develop high-efficiency bifacial perovskite solar cells.
Wow.
It was just published February 25th of this year, 2025.
Very recent.
Yeah, so this is hot off the presses.
Hot off the presses and a hot topic, too.
Yeah.
Solar energy is really having a moment.
It really is. So let's jump right in. Bifacial perovskite solar cells. What are we even talking about?
Okay, so picture this. You've got your typical solar panel, right?
Mhm.
The kind you see on rooftops. But here's the twist. Bifacial cells, they can capture sunlight from both sides.
So like double the power.
Yeah. Think of it like getting a 2-for-1 deal on sunshine.
Okay, I like where this is going.
We're talking about way more energy from the same space, and they can even use that diffused light, from clouds or reflected off the ground. Wow.
Oh, so it's not just direct sunlight. That's pretty cool. Even on a cloudy day, you're still generating power.
Exactly. That's the beauty of it. And then there's the perovskite part of the equation.
Okay, perovskites. That's a word I keep hearing more and more these days. What's the big deal with this material?
Well, it's kind of like the new kid on the block in solar tech.
Okay.
And researchers are buzzing about it because it could be way more efficient than the silicon solar cells that we're using now.
So like even more power than what we were just talking about.
Potentially, yeah. Plus, they're cheaper to make. It's like, why haven't we been using this all along?
Right. So what's the catch? There's got to be a catch.
Well, there has been. The catch with perovskites was they weren't always so durable. Moisture, oxygen, those are kind of the enemies, making them break down over time.
So not so good for outdoor use then.
Not ideal, no. But that's where this new research from the Indian Institute of Technology comes in.
Okay, this is the part where things start to get really interesting.
Yeah, they've developed this new transparent electrode they're calling NAND.
Manti.
Yeah, catchy, right?
I like it.
Stands for Neo/Ag/Neo. Bit of a mouthful.
Okay, so what's so special about NAND?
Well, this is where the breakthrough happens. Not only does it boost the cell's efficiency, but it also solves that whole durability problem we were talking about.
So wait, it's more efficient and more durable.
Exactly.
Okay, now I'm really intrigued. Tell me more about these results.
Okay, so they hit power conversion efficiencies of 9.05% and 6.54% from the different sides, plus a bifaciality factor of 72%. That means it's pulling in light from both sides like a champ.
Impressive. And the durability.
Oh, they ran these cells for over 1,000 hours straight.
Wow.
No protective encapsulation, nothing. And they still kept 80% of their efficiency. That's huge.
That is huge. It sounds like perovskite cells just leveled up in a major way.
They really did.
Yeah.
And what's even cooler is that it opens up all sorts of possibilities beyond just your average solar panel.
Ooh, like what?
Well, imagine this. Skyscrapers with windows that also generate power, or even fields with crops growing beneath semi-transparent solar panels. That's like a whole new world of solar integration.
My mind is officially blown.
It's pretty amazing, right? And that's just scratching the surface. We're talking about potential applications in everything from cars to clothing.
Solar-powered clothes. Now that's a future I can get behind. But hold on. Before we get too carried away with all these exciting possibilities, let's talk about the practical side of things. How realistic is all of this?
That's a great question and a very important one. There's definitely still work to be done. We need to figure out how to mass produce these things.
Right. Taking it from the lab to the real world is always the challenge.
Exactly. And even though they made huge strides with durability, making sure these things can last for years out in the elements, that's still a big focus.
Makes sense. Nobody wants a solar panel that conks out after a year or two.
Right. And then there's the environmental piece, too. We got to make sure the whole process from manufacturing to disposal is sustainable.
So it's about making sure this amazing technology is also a responsible technology.
Exactly. And that's where a lot of the research is headed now.
So it sounds like we've got the potential for a real game changer here, but there are still some hurdles to clear before we see bifacial perovskite solar cells become a mainstream thing.
Exactly. It's a journey, but an exciting one for sure.
It really is. Well, let's dig a little deeper into the specifics of this NAND electrode and why it's such a big deal.
Okay, let's do it. So this NAND, it's a pretty amazing piece of engineering.
What makes it so special?
Well, first off, it's super thin.
How thin are we talking?
Like crazy thin.
Okay.
Only about 40 nanometers.
Wow, that's, for our listeners, that's thousands of times thinner than a human hair.
Exactly. And, that thinness, it's not just for show.
Oh, it's got to be important for how it works.
Absolutely. Like, think flexibility.
Okay.
You could put these solar cells on curved surfaces.
Ooh, like on cars.
Yeah. Or even clothes. Imagine that.
Solar-powered clothes. Okay, now we're talking.
Right. And it gets better.
There's more.
Yeah, it's transparent because it's so thin, so we can use it in windows without blocking the view.
Oh, that's pretty slick.
Right. And all that thinness also makes it superconductive, so you get better electron transfer, meaning more energy.
Okay, so it's thin, flexible, transparent, and a great conductor.
Boom. That's NaN-NTE in a nutshell.
Impressive. But what about the actual materials? What's NaN-T made of?
Good question. It's actually a 3-layer thing.
Okay.
You've got nickel oxide, silver, and then another layer of nickel oxide.
So it's like a sandwich.
Yeah, a high-tech power sandwich.
Aha, I like it.
But each layer, it does something important.
Like what?
Okay, so the nickel oxide, that's a really good charge collector.
Meaner.
So when the perovskite absorbs sunlight and creates those electrons, the nickel oxide grabs them efficiently.
Ah, okay, got it.
And then the silver in the middle, that's like a superhighway for those electrons to zoom through and create current.
So it's all about moving those electrons around quickly.
You got it. But here's the kicker. Those nickel oxide layers, they also protect the perovskite.
From?
You remember the enemies?
Moisture and oxygen.
Bingo. They act like a shield, keeping those troublemakers away from the perovskite and making sure it lasts.
So it's like a bodyguard and a conductor?
Exactly. It's a multitasker.
That's pretty amazing. They really seem to have thought of everything. But what about the cost? Is NaN-T expensive to make?
That's the million-dollar question, right?
Well, it feels like it should be with all those fancy layers and materials.
You'd think so, but actually the materials are pretty abundant, not like some of the rare stuff in other solar cells.
Okay, that's good.
But the catch is figuring out how to mass produce those layers.
Right, making millions of those tiny sandwiches.
Exactly. That's where the cost challenge comes in. Researchers are working on that, though, coming up with new ways to manufacture them efficiently.
Like what?
Oh, all sorts of cool stuff, like roll-to-roll printing. It's kind of like printing newspapers, but for solar cells.
Wow, that's high tech.
It is. And vapor deposition, that's another one, where they basically spray the layers onto a surface.
So it's like we're on the verge of a solar revolution.
Oh, absolutely.
Yeah.
Imagine instead of those big clunky solar panels, we have these sleek integrated solar cells everywhere.
In our windows, on our clothes, it's pretty mind-blowing.
It really is. It changes how we think about generating power completely.
Totally. But wait, there was something you mentioned earlier about NaN-T being good for thermal windows. I didn't quite catch that.
Oh, yeah. Good catch. So you know how regular windows, they let a lot of heat escape in the winter and in the summer?
Yeah, it's a pain, always cranking up the heat or the AC.
Right. Well, NaN-T, it can block certain types of heat, infrared radiation.
So like a built-in temperature control.
Exactly. Keeps your house warmer in the winter, cooler in the summer.
Wow, that's pretty amazing. So these windows, they could save us a ton of energy.
Exactly. And remember agrivoltaics, those farms with solar panels?
Yeah, the ones where crops grow underneath.
Yeah, those. Well, NaN-T could be a game changer there, too.
How so?
Different plants need different amounts of light and heat.
Right.
So with these thermal windows, you could adjust how much infrared radiation reaches the plants.
So you're basically fine-tuning the sunlight for each crop.
Exactly. Happier plants, more food, more energy, everybody wins.
It's like this technology, it's not just about better solar panels.
It's about rethinking our whole relationship with energy.
Exactly. But we've got to be realistic. There are still challenges.
Oh, for sure. Like we talked about, scaling up production, making sure they last a long time.
And what about the environmental impact of making all these new solar cells?
Ah, that's a big one. We have to be mindful of that.
So it's got to be sustainable.
Absolutely. Yeah. Can't just swap one problem for another.
Right. Got to make sure we're not creating more waste or pollution in the process.
Exactly. So researchers are working on that too, looking at cleaner manufacturing methods, using less toxic stuff.
So it's like a balancing act.
Totally. Making something amazing, but also making sure it's good for the planet in the long run.
Okay, so lots to think about. Now, remember that whole solar-powered clothes thing? I got to hear more about that.
Yeah. That one caught your attention, didn't it?
It did. I mean, come on. Who wouldn't want clothes that charge their phone?
This is a pretty cool idea.
But, how would that even work? Are we talking, solar panels sewn into jackets?
Well, it's not quite that simple.
Okay.
There are some technical challenges,
Like what?
Well, first off, those solar cells, they got to be flexible.
Right, because clothes, they move and bend and stuff.
Exactly. You don't want your solar shirt cracking when you sit down.
Uh-huh, no thanks.
And then they got to be tough, too.
Durable.
Yeah, like able to handle being washed and worn and all that.
Right, real life stuff.
Exactly. And on top of all that, they need to be super efficient.
Because.
Well, think about it. A shirt doesn't have nearly as much surface area as a rooftop, right?
Sure.
So those tiny solar cells got to be really good at converting sunlight if they're going to power anything.
Makes sense. So it's not just about, like, slapping some solar panels on a t-shirt and calling it a day.
Not quite. It's going to take some clever engineering, new materials, maybe even tiny little batteries woven into the fabric.
Wow. It's almost like science fiction coming to life.
It is. And, it really shows how this research, it's not just about solar panels, it's about changing how we think about energy in general.
It's like energy is everywhere. We just got to figure out how to capture it.
Exactly. And that's what makes this whole field so exciting. But let's zoom out for a second.
Okay.
We've been talking about all these cool possibilities, but how does all this fit into the big picture? The whole global energy transition thing.
Right. Putting it all in context.
Exactly. Because at the end of the day, this is about moving away from fossil fuels, tackling climate change. That's the real goal.
So it's bigger than just cool gadgets and solar clothes.
Way bigger. This is about the future of our planet.
And these solar cells, they're a part of that.
A big part, potentially. Especially if we can make them cheap and accessible for everyone.
So it's not just about rich countries having all the clean energy.
No way. It's got to be for everyone. Imagine, villages in remote areas, they could have their own solar power.
No more relying on those old polluting power grids.
Exactly. They could be energy independent.
That's a powerful idea.
It is. And even in cities, think about low-income communities, they could benefit too, have access to affordable, clean energy.
So it's not just about the environment, it's about social justice too.
Exactly. Clean energy, it should be a right, not a privilege.
Okay, I'm getting chills. This is big. But how do we get there? What are the next steps?
Well, like we said, making them more durable is still a top priority.
Oh, this got to last, like, decades, right?
Yep, got to be able to handle anything Mother Nature throws at them. And that manufacturing piece, that's huge.
Figuring out how to mass produce them without polluting the planet in the process.
Right. It's all
Yeah.
connected. And of course, always searching for new materials, better designs, always pushing the limits.
So lots of work still to do.
Oh yeah, tons.
Yeah.
But the potential is there. And that's what matters.
It's exciting. Okay, one last thing before we wrap up.
It's you.
We've covered a lot of ground, the science, the potential, the challenges. What's the main takeaway you want our listeners to leave with?
Good question. I guess it's this. This technology, it's not just about solar panels. It's about a whole new way of thinking about energy.
Like a shift in our mindset.
Exactly. We're moving towards a future where clean energy is integrated into everything as part of our lives, not separate from them.
And these bifacial perovskite solar cells, they're a big step in that direction.
They are. They show us what's possible. And that's something to be excited about.
Absolutely. Well, on that note, I think it's time to wrap up this deep dive. Thanks for joining us and sharing your expertise.
My pleasure. Always happy to talk about solar.
Wow, what a journey.
Seriously. My head is spinning with all this solar stuff.
Mine too. But in a good way, right?
Oh, absolutely.
Yeah.
Like this technology, it's not just some incremental improvements, like a whole new ball game.
It really does feel like a turning point. And what's so cool is that it's not just about the tech itself. It's about the bigger picture, the whole vision of a sustainable future.
Exactly. We're not just swapping out one type of solar panel for another. We're talking about a fundamental shift in how we think about energy.
Like moving away from this idea of energy being something we extract and consume.
Toward a model where energy is something we generate and share, something that's integrated into every aspect of our lives.
And these bifacial perovskite solar cells, they're kind of like a symbol of that shift, right?
Totally. They show us what's possible when we combine cutting-edge science with a commitment to sustainability.
And it's not just a pipe dream. It's happening right now. The research we talked about today, it's proof that this future is within our grasp.
It is. But we can't just sit back and wait for it to happen, right?
Right. We've got to keep pushing forward, keep investing in research, keep developing new technologies, keep making these solutions more affordable and accessible to everyone.
Exactly. It's got to be a collective effort. Scientists, policymakers, businesses, even everyday people, we all have a role to play.
So it's not just about the tech itself. It's about changing our mindset, our behaviors, our whole approach to energy.
Right. We need to start thinking about energy as something we generate and share, not just something we buy and consume.
And that starts with education, with raising awareness, with getting people excited about the possibilities.
Exactly, because once people understand the potential of this technology, once they see how it can benefit their lives, their communities, the planet, that's when real change happens.
So it's about sparking a movement, a solar revolution.
Exactly. We need to inspire people to embrace the power of the sun and create a brighter future for everyone.
Well said. And I think that's the perfect note to end on. We've covered a lot of ground today, from the science behind bifacial perovskite solar cells to their incredible potential to change the world.
It's been a fascinating journey.
It really has. And we hope you, our listeners, are feeling as inspired as we are about the future of solar energy.
We're on the cusp of something truly remarkable, and we can't wait to see what the future holds.
So thank you for joining us on this deep dive. And until next time, keep exploring, keep learning, and keep believing in the power of innovation to create a better world.
To a brighter future, powered by the sun.